Well, there's a lot of different reasons, but I'm working with the Jody Mime and the emergency manager to try and change that practice. They're real hesitant because we live in a very litigious society, and if you don't, they prefer to overwarn than to underwarn, and don't want to take the chances that, well, our sirens didn't go off. How many of you people think that the National Weather Service control the sirens? Anyone? Good, because we don't. We never have. That's the local emergency manager's responsibility, and it's usually someone, and not the emergency manager, pushing the button. It's a dispatcher, something like that. But notice that if this tornado is occurring, it's a little tiny dot right there. There's people all over the place. We've already made a big old CYA, if you know what that stands for. We're warning people in a much wider area than the tornado is. And part of that's because we don't know if it's going to take a left or a right-hand turn. They do those sorts of things. And part of it's because these storms usually produce hail and strong winds, other than the tornado, that can cause damage. So we do that sort of stuff. But right now we're running into the problem of in JCPS, Jefferson County Public Schools, if a tornado warning is issued for down south on Dixie Highway for that little peninsula that goes down toward West Point, then there's kids up at Norton Commons on 35 air miles away that are doing this in the bathrooms for 45 minutes, and it's traumatizing kids. So we're trying to get that changed. So anyway, that's a little bit of an aside, but it's some information.
When you say eye of the storm, is that related to the hoop-shaped birds?
What's that?
Eye of the storm?
How strong this is?
The eye of the storm?
The eye storm? Well, yeah, this would be sort of the eye, if you wanted to call it an eye. But it's just, that's where the center of the circulation would be. But it's not like the eye of a hurricane where you can actually look all around. In theory, in the center of a tornado, that's the way it would be. But if you had a tornado that was not moving, you could probably look up and see things going like this. But they move so quickly that it's just a blur. Okay, squall lines. Have you ever seen or heard of a squall line? I'm sure you've seen them. You just might not have known that's what it was called. These are lines of thunderstorms, can be several hundred miles in length. This one, goes all the way from the Great Lakes probably down to Oklahoma. And whenever there's a little kink or a break in the line, that's where you get these little spin-up tornadoes. This is where most of the Kentucky or central Kentucky and eastern Kentucky tornadoes come from, storms like this, not from the big supercells. And the reason that they form is because we've got this elongated storm, and in the center part of the storm it'll start rushing out, and that creates what we call these little bookend vortices. And these little vortices can cause rotations that make it down to the ground. Sometimes this will produce an anticyclonic tornado, which means that it's rotating in the opposite frame of reference of the Earth. Hurricanes, in case you didn't know that, hurricanes in the southern hemisphere rotate in the opposite direction of the northern hemisphere. And that's because of the way the Earth rotates and the shape of the Earth. Because basically what's happening is, hold on, I got a great visual aid. I'll be right back. There we go. Yeah, we got the Earth. If I rotate this in the right frame of reference, in other words, so that the sun rises in the east and sets in the west, and then I look at it from the North Pole, what way is the Earth rotating? Counterclockwise. Very good. That's called cyclonic rotation. That's the cycle of the Earth. Now, if I turn it around, still rotating in the same direction, from the South Pole, which direction is it going? Clockwise or counterclockwise? Clockwise. That's the way all low pressure systems rotate in the southern hemisphere. All systems rotating in the northern hemisphere go counterclockwise. It is physically impossible for a hurricane or a tornado or a typhoon to cross the equator in just reverse direction. So most of the tornadoes that occur are going to be rotating in this direction because that's the favored frame of rotation for low pressure systems, which is what a tornado is. In the northern hemisphere. That's the Coriolis effect is what does that, yeah. That and a little bit of centripetal forcing and stuff, but mostly Coriolis. Excuse me. Oh, now, when we get these these bookend vortices, you also frequently get a shelf cloud along here, and you've probably seen shelf clouds. Anybody ever seen a big horizontal cloud that looks really ominous and scary because it doesn't look like most clouds go up and this one goes sideways? That's what we call a shelf cloud. It happens because you've got air rushing below and it's pushing other moist air upward, and so and sometimes you can actually see rotation in it, and it'll rotate like this, and wherever the air is going up, that's where the moisture in the air cools. Doesn't have to go up very far. It's sometimes just rising 500 feet will cause it to cool and condense and form a cloud. And on the back side, when it's rotating, then it dies out on the other side. So you just get this long, sort of snake-like looking cloud on the front edge of it. If you see something like that, those usually form when you've got winds that are when you've got out ahead of these things, and you can usually estimate the wind speed from that because they form when you've got maximum winds coming out about 30 miles an hour faster than the storm. So if you know the storm's moving at 15 miles an hour, which is pretty slow, you see one of those, you might get a 45 mile an hour wind gust, a few leaves come down. The storm's moving through at 40 miles an hour, and you see one of those shelf clouds come through, that's 70 mile an hour peak gust. Now, is it going to be all along here? No, could be right there, could be right there, could be right there, could be right there. So somewhere along there, if you know the speed of the storm and you see a shelf cloud, you add 30 miles an hour onto it, and somewhere along there, that's going to be your peak wind. Real good rule of thumb.
Is that what turns into a tornado, that horizontal rotation turns vertical?
No. It's a completely different thing. This will just roll out like that, and it'll dissipate. It doesn't just drop down like that.
Right.
But that's a good question. But if there is a tornado associated with it, it's going to be with that break in the line where you have that. And here's the way this looks. This was in. We've actually got a poster in the walls on one of the walls for this one. This is doesn't look real ominous in the reflectivity, but when you look at it in the velocity, you see this little green going toward the radar, red going away. Wherever there was a little break in the line, we get these little red-green kinks. We had this was February 5th and 6th of 2008, we had 26 tornadoes in Kentucky that day. It's known as the Super Tuesday outbreak. Of the 26 tornadoes, I think there were 3 supercells. The rest were these what we call squall line tornadoes or squallnadoes or quasi-linear convective system tornadoes. These little tiny things. Maximum winds on these are usually about 110 miles an hour, which means they're EF0, EF1. The EF scale is the enhanced Fujita scale, and it's a damage scale based on Fujita did his studies back in the 1950s, and he used old Super 8 and 16 millimeter film to measure how far a car was blown, and he estimated wind speeds on that from very archaic films. Now we have much higher degree of precision in determining winds just from empirical evidence. Texas A&M University, where UK's playing this weekend, they have this air cannon that literally shoots 2x4s out into things to see if it'll go through a brick wall or a concrete wall and stuff like that, so they know the wind speeds that cause that sort of damage. But all along this, we had 23 tornadoes that caused all sorts of damage all across central Kentucky.
How big are the pixels in that?
What's that?
How big is the pixel?
How big is a pixel? It depends. Real close in here, you can practically put your arms around it because it gets bigger and wider as it goes out. This is the radar that's located at Fort Knox. When it goes out, it's a 0.7 degree beam width, so it's sort of a pencil width, but as it gets farther and farther out, you can see that it's wider and wider and wider. So it could be 2 miles wide here, and maybe, well, I mean, it's sort of, I shouldn't say you can put your arms around it, but it might only be a couple of yards wide when it's through here. So much higher definition, and that's actually a good thing to point out. We have much higher resolution in close to the radar. It's like taking a picture with your handy dandy, whatever the latest iPhone is, iPhone X, Y, Z, or whatever. They're up to what, 15, 20 megapixel cameras on them now. Anybody remember your first digital camera, that big clunky thing, and you could look it on your computer, and it only used a corner of the computer. It was like, and you could put 3 of them on a floppy, or you could put 100 of them on a floppy because they were such low resolution, less than 1 megabyte or less than 1 kilobyte. I don't know what they were, but that's what we're talking about out here, the lower resolution stuff up there.
So is that why they overlap? So
Yeah, that's why we have radars. We try to, get this, and as the radar beam goes out, it also goes upward. So if you go out 125 miles, you're looking at, I think, about 6,000-7,000 feet up, which is more than a mile up. When you're in close, the folks that have the best coverage from this particular radar, folks at Fort Knox, and in Louisville, that's the reason they put it down here, because you don't get the best coverage right here. It was actually a big deal when we first got the radars. This is called the so-called cone of silence. And the reason that exists is because the radar only goes up so far and you can't see anything right up above the radar. So you didn't want to have a radar right in a metro area because all the people you're trying to protect, most of the people are right here. So you put it outside a metro area. Well, now it's so easy to just click on the Evansville radar, the Paducah radar, the Indianapolis radar. So those sort of cones of silence have disappeared now. So. Okay, we've talked a little bit about wind and tornadoes. Floods. This is the #1 killer in Kentucky and in Indiana if you happen to live on the other side of the river. And with floods, we can have river floods like the Ohio River flood that we had back in February. And you can have aerial flooding. This is actually from a couple of years ago, 2011. This is down near Boston, I think, Lebanon Junction area. And probably recognize that coming down 3rd Street right over by the Yum Center. All of these rivers across Kentucky, because we're such a geographically diverse state, some flow north, some flow south, most of them flow some ways to the west because the higher elevation is out here. And any one of these you can have major river flooding on. But flash floods can happen anywhere you got a terrain difference, which means literally anywhere in Kentucky, except for maybe a few spots out here that you wouldn't even consider being flash flood-like, but I guarantee you can have flash floods in low-lying areas of the west as well. Here's a perfect example of a flash flood area down near Boston. I think this is actually, it's in Nelson County, Nat Rogers Road. We have it marked on ours because there's been several people that have died there. There's no real river there, but it runs down there, and there's there's no bridge, so the road goes right down to it, and this is what happens when you have water coming in. It just washes right through. This is Western Kentucky, where 3 people lost their lives. Western Kentucky's pretty flat, but water's always looking for the lowest spot, and if you try to drive across a flooded road when the water's over it, it doesn't care how big your vehicle is, it'll wash you away. It only takes 1 to 2 feet of water to wash away most vehicles, even a big vehicle like a Humvee. In fact, there was I don't get on social media much anymore because it's so antisocial, but my flood management, floodplain manager friends have been sending me direct messages on Twitter about when they see bad things on Twitter. And there was a Range Rover put out a Twitter thing saying, "Deep water, no problem." Showed got 24 inches of clearance. It's like, that doesn't mean anything. And they were showing a Range Rover driving through it. So I reposted it as saying they would never be Weather Ready Nation ambassadors. And then
the speed of the
it's
water?
the speed of the water.
More than the depth.
The depth will cause you to become buoyant, and it'll make your it's the Archimedes rule. I don't know how much it's going to displace the weight, so you become lighter, and then the lateral force of the moving water is what pushes you off. And over in was it Harrison or Bourbon County, just a week or so ago, a 20-year-old woman was driving, got herself into a foot of water. She was on the phone with somebody, telling them she just washed off the road, got into some sort of hole. Her body, she was eventually found in the backseat of her car under 10 feet of water. So, and that was number 4. That was the 4th fatality in the last month.
I live in the hills above Elkhorn Creek in Frankfort. say I've seen that in flood.
Oh, I bet, yeah.
But then, you know, I turn away from the creek and go about a half mile up this small stream that's normally like this, with lots of dry rocks normally, but man, you go down there after a big rain,
Oh, yeah.
and it's mind-boggling.
Yeah, and don't ever get close to it, because if you, when you're on foot, 6 inches of water will wash you away. You know, I don't know how much you watch Louisville weather over in Franklin County, but 15-year-old Trinity sophomore sucked into a storm sewer, went 100 feet underground in the storm sewer, and washed out into somebody else's backyard. He lived for about a week before they took him off life support. But he was out playing in his own backyard with his 8-year-old brother. Slipped and went, whew. So it's nothing to play around with.
I was going to say, I've been in the creek and I appreciate
Yeah.
the power.
Most people do not appreciate the power of running water.
It's pretty, well, the spring, I was at the dentist and there's this big huge storm going on outside, you know, and I get out and it's over and I don't think anything about it, but I'm going home and there's these big rocks that had washed out into the road.
Oh, yeah.
The road above me was impassable. There were 3 roads that were impassable.
And in those cases, what you do is you wait, because those roads will be passable within an hour usually.
I was going to say, I
Yeah.
went and visited a neighbor.
There you go. That's the smartest thing to do. Worst thing you could have done was say, "Oh, I can get through this." Yeah. This is actually a dam on the north side of the city of Edmonton, or town of Edmonton, down in Metcalfe County. This was the same day that the flood that Opryland went underwater in Nashville. A lot of southern Kentucky got flooded as well. This thing was almost ready to go. We actually issued a flash flood warning because we thought this dam was going to go. I happened to get caught down in Edmonton at that time. I went down to do a damage survey because we had severe weather go through. There was a tornado in Monroe County. I said, well, severe weather's done. I can go down there now. And I made a joke as I was going out. Oh, I'll let you know if I see any flooding on the way down there. Well, that was famous last words, because I got stuck in Edmonton for 4 hours providing on-site support while they thought that this dam was going to go and flood the entire city. This is the spillway, and that's where it was eroding around the sides because it was washing through. They got lucky. Had it rained for another hour, this probably would have gone, and there would have been a wall of water going through the city. So
What lake is that?
that's just a little, I think they call it City Lake on the north side of Edmonton. Yeah, no, not very big at all, but it would have affected that little town. So yeah, I think there's only 5,000 people in town. So normal precipitation wise, it should be no surprise that the closer you are to the moisture source, you're going to have more annual precipitation. And again, over here, you can tell that rain falls on the west sides. And getting across here, anytime you get the west side of the Continental Divide, you're going to have more than on the east side.
What's that number? Oh, you're doing it right now. Just wondering. Yeah,
Number?
It's the next one.
Oh, okay.
Does it.
Yeah.
Thanks.
Average in Louisville we're 44 to 46. I think we're up to 60 some this year already. Yeah, I think we're number 12 on the annually, and we still have 3 months to go. So I'm what's that?
You broke September.
Broke September, yeah. Broke February and September. February, we had flooding all over the place. One of our forecasters was looking at this. Had almost the same amount of rain in September as we had in February. No Ohio River flooding. Nothing. Why? Anyone want to hazard a guess?
Frozen growing.
Frozen and no vegetation growing. These are thirsty plants out here. They soak up a lot of water. When you get that in the wintertime, all the historic floods that have occurred in this area occur in the wintertime. Nothing occurs in the summer because the ground can absorb it. The plants will take it in.
Plants suck up that much water that it helps with flooding?
Yep.
Wow.
Well, that and interception. So, like in the Robinson Forest, we measured about 65% of rainfall can be without transpirated or intercepted.
Yeah.
Oh, it sticks on a leaf and then evaporates and never makes it to the ground?
Well, yeah. So they'll catch a lot of it, just that canopy, before it goes through. So a lot of times if you're out there, especially storms that aren't real intense,
Right.
then they can catch a lot of that in the summertime. Now in the wintertime, when the citrus trees leave it, more goes through. But, like the plants, we just think of them as water pumps,
Yep.
quite honestly.
Yeah.
Thanks.
And snowfall. This is the average snowfall in the U.S. Should be no surprise that the farther south you go, there's less snow than there is when you go up north. In the state of Kentucky, the higher the elevation, the higher the snowfall. And this is a neat little sequence showing you that it varies year to year. I'm going to do this, get down so you can see it. This was 4 years, so this goes 13 to 17, I think it goes. So there's, we had a decent amount of snow, 1 to 2 foot. Our average around here is just under 12 inches for Louisville. So the next year we had a lot, 2 to 3 feet. Still had a foot to 2, and not so much. But you can see the trend going north. Oops, sorry. Okay, how many clicks do I need? 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So it varies considerably year to year.
So that's not quite a long enough indication. That's not climate.
No,
indication.
no,
You would
no.
think the opposite with
Right,
you know,
yeah.
with the longer-
In fact, yeah, and that's something that I can go into. In fact, that's what we're going to do a little bit of. That was then, this is now, this climate. You might, there's a lot of different things that are out there on opinions on climate and stuff like that. And I'm not going to, we could spend the next 2 weeks talking about it here and arguing and but the thing is that, I don't know what anyone's political opinions are in here, but if you believe a politician, and what they're saying about anything, why do you believe what they say about climate? I mean, I've been working in weather for 30 some years, and this is the strangest year that I've ever seen. I mean, weirdest stuff has been happening. But I also know that we don't control the planet. We don't control the thermostat on the planet. We contribute to it. There's, I've got a whole presentation I can go through some really quickly, but it's a lot more complicated than yes we are, no we aren't, and it's not a binary type thing, which unfortunately in the polarized society we live in, people think of it that way. Something about climate, this is what we call normal. That's a 30-year average because, think about it. I can remember back about 30 years. Most people say, 30 years, this is how it's always been ever since I can remember type stuff. I suppose as humans get older, maybe we should change it to a 40 or 50-year average. But 30 has historically been what we call normal. This is the average over 30 years. If we went back longer, it might be a little wider, a little narrower, and for the highs and lows. But these are the records right up through here. So you can see that you can get 1 or 2 standard deviations outside of the norm. But also note that it's pretty much a sine wave. I don't know how much math you guys have had, but sine wave goes up and down, up and down, up and down. And it's pretty smooth. Gets warm in the summer, cold in the winter. Warm in the summer, cold in the winter. Well, this year it's not so much like a sine wave. This year it's more like a step wave or a box wave. This is Louisville. We had real cold springtime, and then boom, all of a sudden May hit and we had summer. And it stayed that way. And this is what I should have gone through and just shown that, we're still sitting up here. We're supposed to be cooling off. Our normal highs are supposed to be 75, I think, for today, 74, 75. And I think we hit 88 yesterday. Our record high for the weekend, we could be pushing, we might hit 90 by Sunday. This is my hometown in northwest Iowa, even more drastic there. We had a cool April here. They had a cold April in Iowa. In fact, April in both Minnesota and Iowa was their coldest on record. Not one of the coldest, but the coldest on record. And their records go back 100 to 150 years. Well, not as long as here. Probably more like 100 years or so. So the coldest April on record, and then the warmest May on record. They went from 100 degrees over here to 100 degrees over on this one. It's like the political climate we live in today. Nothing in between. There was no spring there. We joke we had 6 days of spring. They might have had 3 days of spring. And it's been hot there and hot and humid all summer long. And
What's this rapid change?
that's the thing I don't understand, because I've never seen anything like it. And now I went to a National Weather Association conference in Reno in 1996, and that's the first time that I ever heard of climate change or global warming, whatever. And there was someone from the National EPA. I don't know who over here said they worked for EPA. Were you state or fed? Federal or state EPA?
I work for the state.
State, okay. So, okay, I know Kevin Strohmeyer works there. I don't know if you know him.
I
but
do know Kevin.
Yeah, he's a great guy. But someone from the national EPA got up there and was talking about this climate change that was going to, and you people, you meteorologists, you need to tell the world about it. And we're all going, what are you talking about, you know? And of course we're, weather people. Weather is, climate is just long-term weather. Weather changes, on a daily basis. Climate changes all the time too. It's just not on a daily basis. But one of the things I went out, and it was actually an interesting day because people arguing and all this sort of stuff. I mean, the guy almost got booed off the stage. But I went out to dinner that evening with a PhD meteorologist from one of the universities who said, I work with these climate change guys or these global warming guys, whatever they were calling it at the time. I don't even know what it was. And he said, what they don't tell you is, they're basing everything on CO2, and they hold all these different things as